where do these pipelines tend to break?
One of the biggest challenge and the biggest breakage is the cache. 5 to 10% of data scientists' time is basically the AI ML modeling portion. I've kind of always had the view that data scientists should be more than ML engineer. In Azure, we use MySQL with our Azure credits. We didn't have to really pay for the license. Going over to GCP, that was a pass-through cost. 3 years ago, per se, this would be barely a question. The answer I might give right now.
Hello, everyone. Thank you for listening in to another episode of Data Innovators and Builders. I'm your host, Saket, and I'm here with Joe, who is head of data at the Commons XR. Joe, thank you for being with us today.
Thank you for having me.
Joe, let's start with a little bit about your background and tell us what Commons XR does.
Sure. So at the core, the Commons XR is a behavior analytics platform. We are used in the mental health space to help PCPs, primary care physicians, or mental health providers to provide better care, whether it is through screening, diagnosis, or treatment plans. We have an immersive platform using AR, VR, XR, but also phones, tablets, or any device where a user can go inside an immersive platform. And we have a set of tasks and activities where people can perform things that the mental health providers deem necessary to help with perhaps treatment plans or screening such like a PHQ-9. And then we extract behavior analytics based upon that and provide more insights so that they can have better care and better diagnoses for the therapist and for the client or patient.
So Joe, tell us a little bit about your background and what do you do as head of data at the Commons XR?
Sure. So I started as more of a research data scientist, where I was helping develop kind of more of the insights and the research publications for the company to help establish ourselves in the field. Eventually, what we needed, especially at the start, we wore many hats. I started to delve more into the data engineering side, getting money more of the pipeline set up, figure out how to do the extraction, transform, and loads in an efficient manner, extracting the insights and figuring out the fields that are necessary, delivering the insights, to not only just us internally, but also to any of our, our clients. And then eventually, it started to be more, more into the cloud, and I started to get much more into the cloud services. And frankly, as I keep moving up, the more I realize is, the cost really matters. So I keep trying to make sure that this whole system runs efficiently under a very efficient cost.
Yeah, awesome. I mean, that's one of the things of being in a startup is you get to build from the ground up. You get to make some of those architectural decisions. Here you are applying a very data-driven approach to a healthcare use case. Tell us a little bit about what kind of data do you see in your operations?
So we see, various inputs. Say, we have immersive experience. It's we have a lot of different types of data where we can determine what people are doing, but it's more of the intent, the context is what really we try to have to extract from the data. For example, if we have a certain activity with tasks, we want to ensure that people perform those tasks as opposed to just free into the immersive experience. If they're basically kind of free, it's hard to have the balance as to what is the context, the value, the meaning of the data. When we have more of an intent of what people are doing, that helps with getting the insights of the data. So in essence, I would kind of answer with, there's various, inputs, sensors, not quite sensors like haptics, but like various inputs that can tell you what they're doing, but it's really the context that matters.
So for us in the audience, can you give us an example of what kind of data you see or what sort of activity you might be capturing?
Yeah, so when it comes to an activity, for example, we might have like a one-on-one where we want to get some exposure to someone's arachnophobia, which is fear of spiders. And we may say, hey, please walk down this hallway of spiders. And with that, maybe it could just be as simple of go from point A to point B. But how they do that point A to point B, how long they may take, perhaps where they look, maybe they're looking down or up, or maybe not at all. They're just basically just trying their best to just go forward and maybe bump into a wall because they're not looking. There can be various ways that they accomplish this task. And the way they accomplish that task is, kind of the way that we get insight out of this. And because we have a requirement for the user or the participant to do, it helps us determine the context of like, okay, because they moved here due to this task, we can get some more readings saying, hey, this person is a bit out of their baseline of what we would expect, or what the aggregate of, let's say, our control data would have.
Okay. So from what I understand, for a given person or an experience that you are capturing millions of rows of data, right? Um, as you said, you were building the initial pipelines and the infrastructure. Tell us a little bit about what were the challenges, where do these pipelines tend to break?
Well, I'll start with kind of the blunt one. The biggest challenge and the biggest breakage is the cache, simply put,
Hmm.
right? I've seen the pipeline break in almost everywhere, right? Whether it could be on, where all the IoTs coalesce into, the certain VMs or any sort of data collection space. It could be between the extraction, transform loading process, um, from our databases or to our databases. It could be delivering the analytics. I've seen all of those either break or be very much slowed. Our solutions, I mean, there's a simple solutions where you can scale, let's say the VM horizontally or vertically. You can do either that. With the analytics, you can throw either some more compute or distribute it with like certain Spark, Hadoop, Hive, and anything like that. But we have to also consider like there are a very amount of ways to solve the problem. And I want to ensure that when we solve the problem, it is sustainable for us to do it now and then in the future. So that is really the biggest challenge is, like basically the funding to make sure that everything is efficient. Um, but to kind of answer it a bit more technically with the throughput, the breakage would be typically more at like, the from all of the services going into one spot, which we've solved by various horizontal scaling, ensuring that there's not so many hotspots. Standard system design where you do make sure that everything is spread out as evenly as possible.
Okay. And of course, this is data that's related to healthcare and comes with its own compliance requirements and stuff. How did that sort of maybe get into consideration in your architecture?
That's the interesting thing. When I started, we've always had the compliance. We always built up
Mhm.
from the compliance. Um, my CEO always made sure that we started with the abstraction of that using UUIDs, which is universal unique identifiers. And because of that, I deal with UUIDs, and that gives me the luxury of being able to work with a variety of data while blocked by less red tape because it's already been abstracted. The PII and PHI is already separated out into a different system that I don't really see. I mean, yes, I'm head of data. Obviously, I do have a certain say in the schema, but my operations are usually in extracting the insights of the UUID, so I don't necessarily deal with that in my day to day.
Yeah, yeah. And as you said, you have different interfaces by which you might be capturing data, including I think mobile app, AR and VR technology, right? As you add more data signals, like how does that schema management or that evolution happen?
Yeah, so we do get some data drift here and there, but I
Hmm.
do try to ensure that when we do get more signals or other data, that it is more additive and rather than not completely changing. We do, again, build from the ground up, ensuring that the schema should be able to match any future versions because we are fairly certain that what we're collecting today is what we want to collect tomorrow and in the future. And so anything that is added to it should just, again, simply be either more columns or maybe in a different sense. Um, Sometimes there have been massive schema evolutions, and I have done a few of those. Especially when I had to ensure that things comport to more of a online transaction process. And then to the OLAP side, which is a lot more fluid because it depends on we use a medallion architecture. The
Hmm.
bronze, silver, gold. For those out there, the bronze is the raw data. The gold is the ready to use data for analytics, and then the silver are all the processes in between to get from the bronze to the gold layer.
Yeah. And then the goal there is the ready for consumption, right? And in your case, who is that consumer of data?
The consumer data, so we do have an analytics dashboard as well as
Hmm.
AI reporting. So I ensure that the gold layer is used for both of those, right? Where I ensure that's the APIs where if you were looking at your analytics, whether it's through a graph or through AI reporting or both of them are inferencing the gold layer through an API.
So one of the things that we talked about earlier was that during the course of building an infrastructure, you also did a migration from one cloud to another. That can be extremely complicated in a production running system. So tell us a little bit about how did you plan for it and maybe why you took those decisions.
So the reason why we did that was we got into a different startup founders program, which gave us a huge influx of credits. So this was, for example, from Azure to GCP. We had a huge influx of credits, and that allowed us to, like have a lot more unlocked, especially with the AI capabilities that we were really trying to leverage. So because of that, we wanted to, increase our runway in some sense, and that was the reason why. Now, how to do it was there was a lot of planning and processes that we had to ensure were done, right? So first off, is like, what are the most critical systems and how do we minimize them being offline? Another could be, okay, so let's have a whole layout of systems with the dependencies, with the different environments. And if we were to move these over, do we need any sort of cross cloud connections? Ideally, we try to not have that. And then if that was the case, how do we do that? VPC, peer-to-peer, all that stuff, right? That's what we're kind of doing with, when we can. And then finally, once everything is moved over, not like we try to do again more of a lift and shift if possible, but again, depending on the critical systems, kept offline as low as possible. And then everything else was brought in, the more ancillary, like let's say all the logging or anything else that is kind of more monitoring sense. Then we kind of observed saying, okay, we are on this new platform. Let's run for a bit before we completely, either remove the services from the other one or basically archive it, right? So our data, we would archive it into, say, sorry, archive tier in Azure, which is what it's called, where you only look at it basically once a year, if that, just in case we need it. And yeah, that's basically kind of the story and how we went through this, more or less.
Okay. So, I mean, cost of ownership, specific capabilities like AI, those are good reasons why some of these choices are made in terms of migration. I was wondering if there were any surprises along the way, good or bad?
Well, so that was my first time going between multiple clouds.
Mhm.
So the most surprises was how mainly how GCP also does their thing too. So with Azure, you have more resource groups and items like that. GCP is more like a project base, and that is kind of what they were built on, built from the ground up. So because of that, there was a little bit less flexibility to kind of have people in different environments or projects, if you will, without having to kind of put them at each of them. Now with user groups, it's easy, but it still was something that we had to kind of keep monitoring because we got quite a few more like credential requests saying, "Hey, I need access to this." That also includes when it comes to services communicating with each other, right? Every project has its own service account, as opposed to having things in a resource group in the way we want it. But that said, we did kind of like that project style because it did allow us to really see the billing in a lot clearer light. So uh, there's like good and bad with it,
Mhm.
where it's like, well, I wouldn't even say bad. I would just say it was more of a surprise on, oh, they operate quite differently here, and AWS also operates somewhat differently between the other two as well. So.
Yeah, that's very true. I mean, I think at a compute level, at a container level, things may be very similar, but how do you manage the cloud environment and how do you, operationalize it can vary quite a bit, and there's
Yes.
opinionated approaches there. Yeah.
Another surprise I'll also say was that we in Azure we use MS SQL, and what we didn't know was that using MS SQL with our Azure credits, we didn't have to really pay for the license. Going over to GCP, we there was that was a pass-through cost, where the license to use MS SQL was we were from the bill, and so we realized, oh, this is unsustainable for us. So
Mhm.
we had to choose something else. Postgres is reliable, so we just went with that, and I don't really have much problem since. But we do somewhat miss MS SQL. It was quite a great managed service, but just due to the pricing for us, it just wasn't stable.
Okay. But, turns out good planning and sort of working through the process, running things in parallel, doing that switchover all worked out great overall. So, switching gears a little bit, I think one of the topics we've talked about how, uh, the traditional role of what a data scientist does and what a machine learning engineer does has been converging. So, um, I want to hear your take on, what is happening in your perspective.
So it's a bit strange, right? Because data science has a lot is not really a well-defined title, I would say.
Mhm.
Right. In one company, it could be, hey, you're only just basically doing some SQL and some data cleaning. Another one, you may just be doing pure ML and research. And then you might have more of a full stack style. Whereas ML engineer is a bit more defined. And then I know you mentioned two roles, but I'd like to also throw in data engineer as well. Because to me, it seems that the data scientists, if we everyone see the hierarchy, data science hierarchy of needs, you have at the bottom, you have like your sensor collection, and then you have your wrangling, and then kind of the exploring of the data, right? And at the very top, which is like, let's say 5 to 10% of data scientists' time is basically the AI ML modeling portion. So it's interesting, right? Where data scientists, were hired basically to do more of the AI and modeling, but a lot of times it's basically used to clean up the data, which is more or less kind of what data engineers are doing, but more at scale and more, and make sure that everything is serviced, in a more sustainable way. So because of that, I think the realization is saying, well, yes, I mean, data scientists have to do this stuff anyways. It would make more sense if they would also they kind of do more of the data stack along with deploying the models as well. A lot of data scientists, let's say we have notebooks for more of the experimentation and theory, and then we might use something, maybe provide a dashboard, and then afterwards it might just sit there. The way I see it, the reason is because we're trying to also converge the technical value and the business value, right? Because sometimes what the data scientists may produce might not be exactly the highest ROI from the business sense. When you see ML engineers and they deploy this and have all these ML ops and actual like metrics and it's being used as with the product, you get to clearly see the business value in real time. And so it sounds like it is trying for the data scientists to be closer to the business and providing the business value.
Yeah. I think that's a very important part actually for the data scientist role is to understand the business, understand what are the key levers of the business. That's not that it's not possible. Oftentimes engineers are not necessarily focused on that aspect, right? So if, for example, you know, um, how do we spend on marketing and what does it get in terms of users, right? Understanding that lever is extremely important from a data science perspective to then look at users and spend and all those and sort of come up to the decisions, right? So and it's a definitely a very valid point. How is this sort of convergence maybe changing the hiring approach? Um,
Well, it's interesting, right? All that I said, how I see this,
yeah.
I've kind of always had the view that data scientists should be more as an ML engineer or data
Mhm.
engineers. I kind of want to throw that role back in there. So I've kind of always had this view, and this is also what drove me to kind of be this type of data scientist, where I ensure that I'm more on the engineering side and also more on the pipeline. I kind of like this cross, if you will. I still do the research side, still do the experimentation, A/B testing, all that stuff, along with certain insights. But I definitely get my hands dirty, every week with ensuring that the pipelines and the cloud infrastructure, and all the operations are set. It just seems like a better um, sense of the business. And I mean, let me ask you actually, because
Yeah.
what do you think is the reason why data scientists, ML engineers are kind of converging back from your experience?
So I think that I may not be as deep as you, first of all. But I think one of the shifts that I'm seeing and observing today is many job functions are getting redefined because of LLMs. And what is happening with in using AI models today is that understanding what is the objective or the outcome that we are working towards and what are we trying to build, that understanding of that requirements, what is needed, is very critical. And being able to take that requirement to a model can help you actually build a lot of stuff. So that's why when I say, hey, I would like, you know, a product with these capabilities and features, and I can take that to a Cloud Code or a Cursor or Lovable and get that product built, means that in some ways it's converging for me the coding layer and the understanding the business need level, right? So I've been thinking that maybe it's one of those pieces that's kind of bringing that together, where many job functions, for example, product managers and engineers are sort of converging. So product managers are developing, they are creating prototypes, and engineers are also starting to think like product managers, right?
Another question for you, I guess, is when you so I know you were at NVIDIA and some time ago. Back then, what were data scientists called? Were we more like statisticians, or were we still called that, or were we more like data engineers, software engineers? What were we back
Actually, I
then?
was at NVIDIA a long time
Yes,
back,
yeah, yeah,
and
right.
that's 2002 to
2006,
2007.
7, right?
To be honest, we were in a software engineering team. I was writing device drivers and stuff, and the thought process about data wasn't that sort of top of mind for us at the time, especially for working in a company that's building hardware, and you're kind of for gaming and automotive and all of those pieces. I think that where I started to observe and learn about data was in my startup, where we're building an advertising platform. And then data became much more front and center. And I think that's the evolution that has happened for a lot of us, maybe in the early part of 2010 and so on, is when Hadoop and big data and all this started to come. So the adoption of data, I think, grew rapidly from being a very business or IT centric function to pretty much everything being data driven. Like product wasn't data driven, way back in the day, right? Um, but I would say that I think much of the function at the time that I saw was largely about data analytics, and data science was its own thing where it's about models. And it's a very different world where building a model that you can bring to production could easily be a 6 month to a year sort
Mm,
of thing between the idea to the training to that stuff, and then changing stuff was a lot longer, right? And um, we're seeing a big shift in that, like using LLMs heavily in many of
mm.
these use cases. Um, so yeah, back to that again. I think that the many problems you're solving with LLMs today, so the model creation has taken a little bit of the backseat, I would say. Much of it has become about the prompts, sometimes the fine tuning, and yeah, I mean, roles have changed quite a bit, to be honest. Um,
Yeah, I agree with your assessment that LLMs, due to the kind of the force multiplier that they do with a lot of engineers that can use them well, kind of allows them to do a lot more things. And in essence, almost I would say it forces them to do a lot more things because of the power, and also with some of the insights that it might say. It might make sense to either collaborate more with them or be that kind of point of contact yourself, where like I'm more the product manager side, I might maybe more interface with customers more or clients or other departments more often to ensure that I have kind of the best prompt. So I can do kind of the better prompt tuning, if you will,
mhm.
to ensure that I get the best insight possible from
Yeah,
LLM.
yeah. And you've seen how LLMs and agents have helped you delegate work, in the team, and maybe if you can give a little bit of insight into that, like where you've seen success there.
Yeah. So um, the way I kind of think about it is basically what you said, where engineers are more, or actually just personnel trying to be more multifaceted. I like to think about it as like, okay, you have ownership. So it's more of an ownership model of you own this piece or this piece or this piece. Because of that, whatever that entails, whatever part of the stack that needs, you're doing that, right? So you might be a data scientist, but you might be using Bash inside of a virtual machine, for example, because that is what your requirement is. Um, and or many other facets where job titles are very much blurred. So because of that, I would say, yeah, it's more ownership. So you can extract kind of the best insight from what you're doing and prompt the best. So that's my
Yeah.
I guess that's my answer is basically more of an ownership model of a piece of the product to ensure that they can get the best insight from knowing the different facets rather than having an interface and possibly have things like the loss in translation, have some blocking, some blockages or anything like that.
Yeah, and I think the agency to take on a problem, solve it, the curiosity to learn how to harness, um, multiple agents and tools together to get that work done, it's become a very, very important skill right now. Right. And talking about skills that matter in job, you have been helping or advising or coaching people in boot camps, right? Um, and I'm just curious what you are seeing, between what people are learning in boot camps, what the work looks like, in practice.
Well, so it's interesting, right? In both sides, you get a lot of different backgrounds of people, right? Especially in the boot camps, some make it like people with maybe no bachelor degree to those with PhDs, in mathematics or biology, especially in the data science realm. And a lot of them do find it interesting, um, but there are some things you just don't get in kind of more an education setting, right? You don't get kind of like a lot of, let's say, a lot of, I won't say failures per se, even though that is a common one to say, but basically you see a lot of the problems that might, errors might occur in the industry. For example, when you ask me about, the pipeline breaking on stuff, having that done in real time with the pressure is, you have to fix that and you really have to like test your knowledge on, okay, what can I do to solve this now as fast as possible? And then post-mortem, what is the more sustainable fix to ensure this doesn't happen again, while also ensuring that we can, while we're doing this, maybe make this better. Another is a different style of collaboration, right?
Mhm.
Or really, I would say, I talked about, having blockers earlier. When you're in a more group project, so in the boot camps I've been in, right? Usually, we have a curriculum with X amount of weeks, and they have certain assignments, and usually um, there was one kind of group project, right? So, this data science one, it's usually like, I want to extract insights from these things. Um, but when they're in the groups, the bloggers are typically themselves. They don't ever have to worry externally to their group. Most of the time, what the bloggers are, unless they're the choice of the project, might have that with the data they're interfacing. So what you do with certain things out of your control is also a way to you don't get in the boot camp, but you can only get at certain with experience in certain companies, especially depending on the skill. I mean, I could keep talking. There's quite a few things, other
Mm.
things as well, but at base, I would say it's more of the interfacing, I guess, with other people, right? Or experiencing certain things at scale, right? So when we're talking about the data I have to do at scale, that is a very different beast than even ingesting, like, let's say, multi-gigabyte kind of, let's say, CSV file from Kaggle, if you will, right?
Right.
So that is basically what my answer to that is. I would say
Mhm.
depending on their background. Some of them might have some systems background, but not many of them have like software engineering background. That's
Yeah.
kind of why they're there.
Yeah, yeah. And I was curious, one of the things that always keeps coming up is how does the adoption of AI change entry level jobs, right? And people, when you said they may not be coming from a software engineering background in a boot camp, they're learning through that, getting into those entry level roles. I was curious how much, that the education process has changed in there, whether, I'm sure it was no LLMs a couple of years back, and how native is it like, yeah, go ahead and use that or avoid using it, learn doing things by your
That
hands.
is a
How's
funny
that?
question, right? Because like 5 years ago, or even 3 years ago per se,
Yeah.
this would be barely a question. And then, the answer I might give right now is going to change in 3 months, six
Mhm.
months. I mean, agents, LLMs are just moving so fast. It's really hard to predict what the the end stage of this is. End stage maybe even being this year or next year. So the curriculum kind of changing. And so I'll also be honest too, like I haven't really mentored many boot camps in the past, let's say 12 months or like that. Because I've been trying to keep up and learn with this wave of what's going on now. But I have seen that curriculums do, they still keep the classics, right? Especially in the data science. They keep the classics of, like, hey, here's all the basic ML models and different classifications. And here, and you could also do, here's how you fit the deal, train test split, all that stuff. But the LLMs, depending on the bootcamp, it seems more not like an afterthought, but not core to it. And I understand that in a lot of companies, LLMs agents are core to a lot of the workflow of the personnel. Um, so I would say it's not catching up as fast as I would think, depending on the bootcamp. Some are. Some are very like, hey, this is the future. You must do it like this. But I would say the more kind of traditional institutions, um, they still try to keep the classics. And while adopting a disruptive technology, but not disrupting the curriculum as much as I probably would personally.
Yeah, I mean, I would say that anybody coming to boot camp has already shown the initiative and the willingness to learn, and I think that serves you well in the AI world. We all have to be learning, and the ways of doing work are changing constantly.
Yeah, I
So,
would also add that you must have good critical thinking as
hmm
well, right? Because we talked about the kind of like the prompt tuning, if you will, or having trying to get the best prompt, but also assessing too what is the LLM's output, right? And especially too when you want to be useful to LLMs, you want to make sure that you are the person that says that is quite good in the domain, that you are the subject matter expert in something. You can be a strong evaluator of yes, what this is telling me is correct, or ah, there are some nuances here. While it may be technically correct from a business sense, it is, there's a better way we can do this. And that's where a lot of the human value is because remember, we're interfacing with other humans. And yes, LLMs have like, the internet, all coalesced, in their memory in a sense, but uh, accessing that not only to, solve more standard problems, but also anything that may happen today, tomorrow. Um, you kind of do need a little bit of more creativity and more case by case assessment. Um, and so that's kind of where you can provide value is using your critical thinking, making sure to think of things holistically, um, and do not only just rely on just the agent output and just like copy and paste it and say, okay, I'm done. Make sure that you validate it. And that is where I think a lot of the value is still going to remain, even in a highly agentic world.
yeah, no, very true. Outcomes matter, and then yeah, you have to see the whole problem end to end, right? Um, so, for data leaders, any word of advice you have? You've been dealing with data at scale, as we said, millions of records for each patient. In your case, you've done cloud migration, you have done significant cost sort of efficiencies as well. So, what would you suggest to data leaders out there?
I mean, kind of the old adage of like, making sure you evaluate the trade-offs is still true today and will always be kind of more true as time goes on, with the scale of things and with some of the specificity of things coming out, and how useful they are. But when you do choose kind of more specific things, you do lose flexibility Or if you do choose to do something a bit, hey, more powerful, more compute, if you will, you are giving up certain, like certain cache or anything like that, or
Mhm.
you might be hitting your quota a bit quicker. So you have to ensure that holistically, what are the business implications of what choices you're making, right? You also have the engineering implications like, hey, when I do this, when I do it this way, this solves the problem from a technical sense. Great. But from a business sense, like, if you do something and then it might make the product cost like, let's say 5% more, you only have so many of that before before like customer churn really goes up, right? There is a
Mhm.
certain limit that like a threshold that once you hit it, it's saying, well, we can't really afford to raise the price anymore unless the feature that we're adding really adds a lot of value. Um, so yeah, I would say make sure that you evaluate your trade-offs, but at a more holistic point of view, not just from a technical standpoint, but also, what are the business impacts of the choices that you make?
Okay. And before we wrap up, I'm also curious about, as you have been exploring AI yourself, like what are maybe some of the tools that you have learned to love or rely on? Anything you want to share with us?
I mean, whenever I do like any personal projects, I do try to explore,
Mhm.
very different facets, like let's say Hugging Face, LangChain, Codex, Squad.
Okay.
Um, Personally, we do like, well, we really like, for example, BigQuery.
Okay.
So that is something that, we know there's different platforms out there, but BigQuery for us has been, we're able to keep the costs quite down, and all the efficiency is great there. We do kind of like the model garden from any of the cloud platforms, really. Um, but yeah, other than that, we also like Gemini a lot for our healthcare LLM. We're trying to
Mhm.
explore some more LLMs to see, hey, what's kind of like the best output for our AI reporting aspect. But currently Gemini and Google with their Google Health data, they really do have kind of a more nuanced output that we kind of use for a product
Okay.
that we do appreciate.
Okay. No, that's great. Some good pointers for us over there. So, yeah, I mean, this is fabulous. I mean, I really enjoyed how you've taken the data and the sort of AI, the convergence of the machine learning and the data science roles and so on. So, great talking to you, Joe. It's been a pleasure. Thank you so much for joining us today.
Yeah, thank you for having me, Saket. I really appreciate it.
Thank you.